All right, good morning and happy Monday. Planning on doing LeetCode contest 304 from last Saturday. So let me share my screen and let's get to it. All right, here we go. Time to shine. Open these guys up. YouTube. Okay. Make array 0 by subtracting equal amounts. Just perform the simulation, I suppose. All right, whatever. Nothing too fancy, right? Okay, so 5:47 a.m. implementation, Python 3. Game plan is to perform simulation. Simulation. Okay. Okay, so wow. All, well, not all x equals, let's see, x for x in A. Count operations, return. Count equals plus equals 1 for each iteration. Low equals min A. Or let's see, A equals x in A maximum of 0 and x minus low. All right, something like that. Uh-oh, something's not right here. Oh, wait, low cannot equal 0, though. All right, so, okay, we'll do a linear scan, fine. Hold on. That's an incorrect first solution. But we see if we can do linear scan, then fine, we'll create B from A or whatever. Equals this for x in A. Low equals so maximum value. 1, 2, 3 is fine, it doesn't matter. If x low equals min low x, else that's fine. B dot append x. Oh, actually, yeah, let's just do this. Hold on. Low equals min x for x in A if x. Right, that's fine. And then A equals max is 0, x minus low, or x in A. That should be fine, right? As long as it's non-zero, right? We actually get somewhere. 0, oh, need to actually increment count, right? Okay, That should be all right. 3 and then 0. Okay, that's cool. $47. Big money, no whammies. Yay. Okay, so 547 to 551. 4 minutes for the implementation Python 3, which is accepted. Oops. Oops. CD. Yay. Okay, let's just post this here real quick and then move on. Nothing too fancy. Use solutions. All right, I can form this simulation. All right, whatever. It's easy. You don't need to give it too much thought because the size is only up to 100. All right, so there's our catch, which will return at the end. Not all of it again, end. All right, so it's not all zeros. Find the minimum non-zero value. Okay, so 1, 2, 3 is a magical value that's larger than any possible value. Low. All right, and then more. Let's just do this transform. Actually, hold on, let's do this. Oops. Maximum of 0, maximum is low. Low will capture and lambda value. That's good. Okay, something like that. Whoa, what is going on here? Doesn't like that min element. Oh, okay. Min element doesn't take that, does it? Let's see what we can do here. Okay. Have a custom comparator. All right, that's fine. We have to do it like this and auto load 1, 2, 3. Okay. Whoa. Good enough. Mhm. Okay, so a dot every right. Count on each iteration. Equals a dot filter x. Take the minimum of that. Minimum of those. A equals a dot map x dot maximum of 0 and x most low. Okay, something like that. Looks good. It's cool. All right, I'll do Kotlin and then move on. It's good enough. Count. So does equal 0. Oh, they're all not 0. Find below. Manipulate A here. Oh, I'm gonna stand up here. Still feeling kind of worn out. I had the COVID last week. Okay, so yeah, that looks good. Let's run this, see what happens. Uh-oh. List. Okay, that looks good. Okay, it's cool. Right, perform the simulation. subtract minimum value, minimum non-zero value low from all elements x of the input a. Continually. That's cool, right? Good enough. All right, let's move on, right? Post that thing. Cool. All right, maximum groups entering a competition. Oop. Okay. Maximum number of groups entering a competition. Interesting. So the sum of the grades, the ith group has to be less than the sum of the grades and the amount of students. So it makes sense to have one student, then two students, and three students. How do I know what value to choose for the first student, though? Interesting. How do you come up with this in your linear time, though? N equals 185. So we need a near linear solution, near linear runtime solution, right? 3, 5, 6, 7, 10, 12, 1, 2, 3, 4, 5, 6, 5, 6. This one looks tough for a Q2. Seems like a good question. I'm not seeing exactly how to do this. I wonder what would brute force, oops, solution look like? I mean, it would obviously TLA. Let's skip ahead for this one. It's only a 4-pointer, so I think there'd be an easier solution to it, but I'm not seeing it. Is it greedy? 12, then 13. And 12 is the maximum value. What if we make greedy solution? Greedy? If we can sort and we can, what if we grabbed, let me just say the first one is this guy. All right, maybe first group. Second group could be that easily. 5 plus 6. I mean, that would work, right? Third group. Maybe 7, 10, and 12. And that works too, right? I think. Let's just write it and see what happens then, right? Worst case, I get it wrong. Okay. Keep track of the last group. Retry X and input array A. Group is an array. If linked the group, then that's one case. Otherwise, for the initial case, turn group. With this, sort it, right? That's sort, then first group is that guy. Okay. CT will be our current total then for each group, right? So T plus equals X. If X exceeds the last group, and we have to keep track of the group size as well. Okay, let's see. So size, or actually what we need, the amount of people that we need is 2. Size is 2. if need is less than or equal to 0, and total exceeds the last group, then we'll push that onto the group, right? Group append total. Oops, hold on, total. And then need equal the length of the group plus 1, right? So when there's 2, then there'll be 3. Okay, maybe something like that. 3, and then the other one's 1. Okay, let's see what happens. Oh, yay! Yay! So this was cool because I totally didn't really believe in myself, but just tried it anyhow. The example given is misleading. The algorithm is greedy, and the solution can be derived. I guess the best solution multiple ways. Okay, it's cool, whatever. All right, so good to try, good to believe in myself. And yeah, it doesn't have to be anything too fancy. Good reminder. View solutions. Greedily consume. Let's see, sort the input array A to greedily consume the smallest values first. I guess the minimal values. Yeah, good enough. Kotlin, let's do this. Kotlin, then JavaScript, 3, C++. Okay, yeah, it doesn't have to be perfect or whatever. Oops. Okay. So a VI group sub 0 size value x and input array a. Let's do this. Put an FML array there, so we can skip the first one. And then need total and need. Okay. T plus equals x minus need. If need is less than or equal to 0 and total exceeds the last of the group, back is less than t, then t equals 0, need equals group size, and plus the group dot size, then group push back t. Okay, something like that. Uh-oh. We've had binary operations. What? What is going on here? What? X. T plus equals X. What's going on? Oh, that is a value, isn't it? No, really? Oh, what am I doing here? This is fine. Explicitly state that it's a vector of integers? Oh, I do, okay. Yeah, otherwise it's an iterator, I guess. Okay, fine. 3 and 1's cool. Okay. Oh man, my legs like keep going numb. This is messed up. Oh. Ooh, okay. Yeah. Stand up again. Oh, my right foot just keeps going numb on me. Sucks. Oh well, at least I'm not terribly sick. Last week I just had fever like the whole week. That sucked. Still recovering. Huh. Yeah, I'm old. Okay, whatever. I do the best I can. That's all I can do. Okay. First one, group, length. Okay, oops, length. Oops, sort it. Sort. Need a sort. Sending order. Okay. Oops, hold on. Yeah, I only want the first one onwards. Just slice. I think that works. Hold on, let me just check. Yeah, that's cool. All right. Yeah. Okay. So let's do this. Let t need so 2 t plus equals x. Well, so need. Oops. If need is equal to 0 and group subgroup length is 1. And so if the total exceeds the last group's total, group dot push t equals 0, need group dot length plus 1 plus that. Okay, that was cool. That's good. All right. Bam. Kotlin next. Kotlin. Okay. Group is a mutable list of integers. Return group size. 0 will be the first one for x in slice 1 t need equals pair 2 t plus equals x. Just need if need is less than or equal to 0 and the total exceeds the last of the group. Last group dot add t 0 need equals 1 plus the group dot size. Okay. Uh-oh. Slice 1 to the end. Tell size. Uh-oh. Oh, I need to sort it. Sort. Oh, should I just sort this? Wait, yeah, I gotta sort. Okay. Nothing too fancy. It's cool. Okay, it's cool. Let's just do this one in Rust, just for fun. Vector integers. Let's see. Mute group vector 0. Length. Okay. Take a slice like that? I don't know. I don't know if this works or not. No. Let's do this. For I and 1 to the length, 8 at length. Just do a sub I. It's cool, whatever. Actually, hold on. T plus equals a sub I is fine. Need equals 1. If need is less than or equal to 0 and the total exceeds the last group. Under rest last element of vector. Is there like a last or a back? Self-dot last. Does that work? Hold on. Where's the documentation? Last vector. Last. Oh yeah, there's a last. Okay, cool. Okay. Group. Push. T equals 0. Need equals 1 plus the group length. Something like that. Oh. Expected enum option. Right, that guy. Borrow that thing. All right. So two, and then borrow T. This guy mutable. Mutable copy of A, so we can sort it. First assignment to T. Mutable. Yes, I do want that to be mutable. This guy I want to be mutable as well. Looks good. Yay. Okay, so that's cool. It's a decent solution, whatever. Nothing too perfect. Good enough. All right. And closest node to two given nodes. I'll grab some more coffee real quick. I'm still worn out. Okay. Ugh. My head hurts. All right, whatever. The show must go on. Ugh. Sit back down. My foot doesn't go numb again. It sucks. All right. Okay, let's read this. You're given a directed graph in nodes. All right. Most one outgoing edge. Okay. It's directed. Already. All right, there's no outgoing edge. Snake one. Two integers, node one and node two. Return the index of the node that can be reached from both node one and node two, such that the maximum between the distance from node one to that node and from node two to that node. The maximum is minimized. Smallest maximum. Return the node with the smallest index. If there's no possible answer, it's just returning of one. Now the edges may contain cycles. There's two outgoing edges. Or no, the outgoing edge goes 2, 2. 0 points to 2. 1 points to 2. 2 points to 3. 3 goes nowhere. So basically, the index of the node can be reached from both of those. So it's the first node they can both see. So we want to minimize the maximum. Oh. Okay, let's see. 0 points to 1, 1 points to 2, 2 points nowhere, 0 and 2. Output is 2. Okay, so this one, node 2 is the answer itself. So one of the nodes could also be the answer. Okay, so 25, simple constraint. Oh, man. Oh, my head hurts. Yeah, I'll be right back. I gotta take another break. Ugh. Alrighty, holy cow. Oh, all right. Hopefully my stomach will get back to normal here pretty soon. Okay, so anyhow, what's the game plan, right? It's obviously a graphing algorithm, and those are most ones I know are linear, near linear, so they should work. So, right, it's just the shortest path um, from the source node to all other nodes. We can perform. Let's see, should do breadth first search. Breadth first search per depth. Seems to make sense, right? So for each depth, see, okay, is there something that we can see from both of those nodes, right? BFS from two sources, right? Okay, so here's the game plan. 635. Oops. It's for implementation in Python 3. Game plan here is to create. No, actually, yeah, just BFS, right? BFS from source nodes. Let's call it S&T. It doesn't matter, whatever. Here's our array of edges, S&T, be our adjacency list. Just call it GJ. Okay. -1 if we're not able to find anything in the end here. K equals length of Q. Q, current node, let's just call it U. Then there's, oh, okay, so if it's been seen, right? Seen is a set is T. U has been seen, but has V been seen? Candidates. Okay, then our candidates. So if length of candidates turn the minimum of those candidates. If say V equals adjacent U, if V equals -1, let's continue. Otherwise, it's not -1, then see if it's been seen or not. If V and seen and that append V, otherwise add V to seen, Q dot append V, seen, add V. Two nodes. Okay, so that looks about right. Let's see what happens here. Two, okay, two's cool. Two for the other one as well. Two, okay. Something like that. Big money, no whammies. Oh, expected 0. Output's 5, I expect 0. And 0, 0. Oh, they're equal. Okay, if they're equal to each other, and that's a corner case I missed. If S equals T, turn S. Big money, no whammies. Uh-oh. Thought from an empty deck. Q to pop left. Length of the queue. Okay. What? That's the length of the queue. How is this possible? Well, length of the queue. Oh. -1 and 0. 1 points to 0, 0 points nowhere. 1 points to 0. Should be 0. How is this going on here? Length of the queue is initially 2. Let's walk through the code, right? What the heck's going on? Oh, yeah, was it 6:41? 6 minutes. Results. Wrong answer. x. First mistake was corner case, right? Second mistake, I'm looking into, right? What's going on here? This guy. So the graph looks like this. Node 0, or node 1 points to 0. Right, so this guy's S, that guy's T. All right, so Q equals 1 and 0, seen 0, 1 and 0, right? V is 0. V in scene, it is. It should be added here. How is it possible that it's not in scene? It did return here, right? So length is 2, canvas is empty. The first one I'll pop is 1. Hmm. How is it continuing though? Candidates. Candidates somehow is V has to be in scene, right? V as 0 is in scene. 0 in scene, right? How is it not in wait? Yes, 0 in scene. Candidate should append. What the heck is going on? The continues breaking it. I see. Well, if v does not equal -1, I see. So we do need to decrement k without continuing. Okay, that makes sense. Oops. Alrighty. Gotta watch out for the continues. Okay, let's do this. Do the sample test cases. Make sure that one's cool. All right, looks good. Oh, Okay. Having a hard time here. Get some more coffee. Okay, so it's supposed to be not possible. Okay, so 0 points to 5. 4 points to 1. Here, I'm better off using pen and paper to draw this graph. One sec. Yeah, this is super boring, but whatever. Who watches these things? I don't know. Anyhow, let's see. 0 points to 5. Or, yeah, 0 points to 5. 1 points to 4. 2 points to 5. 3 points to 4. 4 points to 3. 0, 1, 2, 3, 4. 5 points to 6. 6 points to nowhere. Oh, they're two completely separate graphs. Starting from 0 and 1. Okay, so these are disjoint. Okay, so output 4 because that's the loop and I see it twice because of that loop. I need to see it from each. It needs to be a single connected component. If it's not a single connected component, then there is no solution. So the question is here, how do you determine if the graph is a single connected component or not? I think that's the only constraint, right? So is it possible to have a singly connected graph that doesn't end up at a node? I don't think so. Right, so so to determine if it's a singly connected component, we can just do a depth first search, I suppose. It doesn't really know if we can do that with the breadth first search, the BFS, I suppose. Or should we color nodes? BFS on this guy. Assign them a color. You've been colored already. So in addition to BFS, we can color the graph. So BFS from source to destination to source, one way or the other. Right. I want to keep it super simple though too. So I guess we can BFS in both directions, right? And starting from S, then BFS, starting from T. Instead of doing them both simultaneously, I do them sequentially. Sequential. This is my old solution, right? It is a decent start. Okay, so here BFS. Okay. Okay, so I don't want this to work, right? Do the BFS from one side. Or now, maybe I'll just go back to my old solution, right? And just make sure it's connected component. This is kind of a hack, but whatever. Kind of wacky. Just use this solution. Ensure one single connected component. Turning. Does that work? I don't think that works because the cycle still cause a problem, won't it? Yeah. Dang, okay. So no, I don't think that will work. No, okay, so I do need to come up with an algorithm that'll work on a disjoint graph. Cycles. Keep track the last scene, maybe. That'd be beneficial. Oh, okay, so I don't want to structure this thing. Like I need to like back up actually. I need to back up. Oops. And come up good game plan, right? Okay, so let's keep it super simple. So how can this work? Oh, okay, yeah, let's just do this, right? Let's just do single source shortest path, right? Choose any algorithm. Yeah, JK is TRA. Or whatever. Then place candidates to buckets. That works because I want them to minimize the maximum distance. So distance from S and T. The bucket is the accumulated distance. Candidate node W S T. So abandon breadth first search, right? And we'll just do distances, candidates per distance. Let's just do Bowman forward, it's fine, right? Oh, start a node and return the distance. N equals efficiency list. Max the edges n minus 1 times. Okay, short distances. Distance to you exceeds the distance. Wait, hold on. There's no cost of each edge. All right, so we should just be able to do a BFS from source and then create the distance array, right? Distance is simply the path length, right? Nothing too fancy. Okay, distance scene at s. Okay, so distance s 0. S scene s distance s0. Right, that's cool. Yeah. Otherwise, if it's cool, let me say q dot append the add b. Okay, so reference search and then distance is depth, basically. Depth 0. Depth. Distance to you equals that depth. Depth equals 1. How much time do I have left? 4 minutes. Okay, quick. Quick. Come up with a better game plan and implement it. Okay, so B equals distances from each of these things. 1, and that should be 2. 1 and 2, 0, 1, 2 and 3. 2 is the minimum distance. 3 is the total distance is 1 plus 1, and 2 plus 1, 2. Right, okay. So then we can zip them. C equals zip AB. Here. Accumulate the distances. And we'll return the minimum of that. Minimum of the distances. Uh, just ask SDT. Not SDT. How about distances from S's perspective? Whatever. A and B is fine. You want to call these things though. Let me get into here. Basically, want to say these are our candidates. This is our minimum candidate. Minimum candidate. Just accumulated sum of those two values. Y for XY and zip AB, which would be C, right? And take the minimum of those two, which would be this guy, that index. This inf low, that's some that's 1 for X and C. Index 1. Index if X is less than infinity, I guess we can turn I, right? Well, we want the smallest value, right? Not just any old value. Right, yeah, so if X is less than low, low equals X, index for I. Something like that. No. cannot unpack. Oh, I need to enumerate. Right. This guy, so you can take the index of it, so iterate through it. Okay, so says 2 is correct. One should be 2 as well. Cool. Okay, so then go to what did I miss? Hold on. Let's not read this, but I want to go to this guy. Then my wrong answers. Oop, hold on. This guy. That guy. And this guy. Okay, make sure these are all cool. So it should be 0, 0, -1, right? This one is going to be 0. That's -1. Okay, that looks right. Now let's see what happens. Pretty sure I'm past due time. Oh, wrong answer again. Okay, the contest ended and I got another wrong answer. Okay. Absolve it later. Catch you next time.